Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Before we dive in, let me ask you something. How many devices have you touched today? Like your laptop, your smartphone, or maybe your smartwatch? We interact with computer constantly, yet most of us have no idea what's actually happening inside of them. Today we're going to change that. My name is Raihani Rasyaki, and in the next few minutes, I'm going to take you on a journey from the tiny electrical signal that make up a single bit of data, all the way to the powerful chips now driving artificial intelligence. So sit back, stay curious, and let's get started. A computer is an electronic device that processes data according to instructions. It accepts input, processes it, stores result, and produces output, all at remarkable speed. Computers come in many forms: desktop, laptop, tablets, smartphone, servers, and embedded system inside cars or appliances. What they share is the same core architecture. Modern computers rely on two fundamental layers: hardware, physical components, and software, programs, and operating system. Neither works without the other. Okay, types of the computers. 1. Personal computer or PC. Designed for individual use, include desktop and laptop use for work, gaming, and everyday tasks. Number 2 is server. Powerful machine that store, manage, and distribute data to other computers over a network. Number 3 is workstations. High-performance computer for specialized tasks like 3D and rendering, engineering, or scientific simulation. Number 4 is embedded system. Smart computers built into devices like microwave, cars, or medical equipment to control a specific function. Number 5, supercomputers. Extremely powerful system used for complex scientific calculation, climate modeling, and AI research. Core hardware components. Every computer is built around several essential hardware components. Together, they form the physical foundation that makes computing possible. Like CPU, RAM, motherboard, storage, GPU, and last power supply. Each component plays a distinct role. Removing or guarding any one of them affect the entire system performance and reliability. The CPU, or Central Processing Unit. Often called the brain of the computer, the CPU executes instructions from programs by performing arithmetic, logic control, and input-output operation. 1. Clock speed. Measured in GHz, it indicates how many cycles per second the CPU can perform. Higher equals to faster processing. Number 2, cores. Modern CPUs have multiple cores, each capable of handling tasks independently for better multitasking. Number 3 is cache. Small, ultra-fast memory built into the CPU that stores frequently used data for instant access. Number 4 is major manufacturers. Intel and AMD dominate the desktop or laptop market. ARM design power most smartphones and tablets. RAM and storage. RAM, or we call it random access memory. Temporary. Fast memory used while the computer is running. Number 2, holds active programs and data for quick CPU access. Number 3, clear when the computer is turned off. Number 4, typical range, 8 up to 64 GB for consumer PCs. A storage, or HDD or SSD. Permanent storage for the US, apps, and files. HDD use spinning disk. SSD use flash chips much faster. Number 3 is data is written in when the power is off. Number 4, typical range, 256 GB, several terabytes. Okay, the motherboard. The motherboard is the main circuit board that connects all the components. It provides the pathways. Call it BIOS, through which data travels between the CPU, RAM, storage, and peripherals. 1. CPU socket. The slot where the processor is installed must match the CPU's socket type. Number two is RAM slots. Hot memory modules. More slots equal to more potential RAM capacity. Number three is physical slots. Conic expansion cards like GPUs, network cards, and NVMe SSDs. Number four is BIOS or UEFI chip, firmware that initializes hardware when the computer boots before handing off to the OS. Number five, I or O ports, USB, HDMI, audio, and Ethernet ports accessible from the back panel. Okay. The GPU or graphics processing unit, originally designed to render image and video. GPUs have become essential for far more than graphics. Their architecture, thousands of smaller cores working in parallel, makes them ideal for any task requiring massive computation. 1. For gaming. Renders complex 3D scenes in real time at high frame rates and resolution. 2. For video and creative work. Accelerate video encoding, photo editing, and 3D modeling. 3. AI and machine learning. Training neural networks requires GPU-level parallelism. Models like LLMs are trained on cluster of thousands of GPUs. Number 4 is integrate versus dedicate. Integrate GPUs share system RAM and switch everyday tasks. Dedicated GPUs have their own FRAM for demanding workloads. Input, output, and peripherals. Peripherals as external devices that interact with the computer. They are classified by the direction data flows. Input device. It's like keyboard, mouse, touchscreen and stylus, microphone and camera, scanner and barcode reader. Output device is like monitor and projector, speakers and headphones, printer and plotter, haptic feedback device. Okay, key takeaways. 1. A computer is a system of interconnected hardware components working in coordination governed by software. 2. The CPU processes instruction. RAM holds active data temporarily, and storage retains data permanently. Number 3 is motherboard. The motherboard is the backbone that connects every component and enables communication between them. Number 4, GPUs. Originally for graphic, now power AI, scientific computing, and data-intensive application. Number 5, the last, peripherals extend for a computer's capabilities, allowing users to interact with and receive output from the system. Okay, thank you for your attention. I hope this presentation encouraged you to understanding the computer and hardware essential.